Hi guys, this is the Innovative Minds Tutor. Hope you're well, guys. We are still working on paper one prelim. Yes, this week we'll start paper two, guys, as we are preparing for uh, this prelim 2023 preparation. So actually, the paper that we're looking at here, it's prelim Gauteng 2022 grade 12 paper one. If you are new to this channel, what are you waiting for? Kindly subscribe. You only subscribe once. Thank you, thank you. Without wasting time, let's get to today's video. We start at 7.1. At what annual percentage interest rate compounded quarterly should a lump sum be invested in order for it to double in 6 years? How many marks is that? That's 5 marks. Actually, this is an easy 5 marks. How, guys? Let's put this into practice. Firstly, you are being told at what annual percentage interest rate. They're looking for the interest rate, which is I in this case. And that interest rate, remember, it's compounded quarterly. So since it's compounded quarterly, it means that you're going to divide I by 4 since it's compounded quarterly. So what about the period, or the period in years? That will be 6 multiplied by 4, which will give you 24. Okay. They also said that should the lump sum be invested in order for it to double in 6 years? So let the present value be what? Be X. And the amount be doubled, so it will be 2x. So remember that what we're looking for, it's I here. So we are going to use a compound formula. Right, the compound formula, it's A is equals to P 1 plus I to the power of N, in which A is 2x, and this is x, and we are going to have 1 plus I divided by 4, which is to the power of 24. First thing, you have to get rid of x. We are going to divide both sides by x, so we have to get rid of x. So this and this, they go. We are left with 2, which is equals to 1 plus I divided by 4, interest rate divided by 4, which is 24. So we are going to say 24 root 2 as well as 24 roots here. So after that, we could see that 24 and 24, they go. So we are having 24 root 2, which is equals to 1 plus I divided by 4. So we are going to multiply by 4 in this case. So multiply by 4 in this case. So this and this, they go. Right, so we are left actually with 1 plus, it's 1 plus, right? So the best way will be 4 to, remember this is 4 and 24 root 2. Okay, then minus, take 1 to the other side, minus 1, which is equals to I. So let's put this in our calculator and see what we are going to get. So in our calculator, we will see what we are going to get. If you put this, let's say you punch this in a calculator. How will you punch it? Let me just say, all right, 4, then 24 root, that's 24. Okay, let me change this calculator. It seems it's not doing what it's supposed to do. So remember that here it's 4. Okay, and we have 24 root 2. Okay, minus 1. Oh, okay. Why is giving this? It's not giving, huh? It's not giving. Hey, there must be a mistake that I made here. There must be a mistake that I made there. Why is not giving? So what are we going to do? Oh, this one should be inside the bracket as well. Oh, my mistake. Okay. Right. So that means before I substituted here, I was supposed to put that one. So I it's what? It's equals to 0,1172089466. So let's multiply that with 100. Remember, looking for the rate. So that would be 11,72, correct to 2 deciplaces. So we are having 11,72%. Yes, right. That's how you should get that 5 marks. Remember that we were focusing on this 5 marks, right? Okay. Hope you're well. Let's go to 7.2. Simon buys a furniture to the value of 10,000 rand. He borrows the money on the 1st of February 2020 from a financial institution that charges at an interest at the rate of 9.5% compounded monthly. He agrees to pay the monthly installment of 450. The agreement of the loan allows him to pay equal monthly installment from the 1st of August 2020. Now at 7.2.1, calculate the total amount owing to the financial institution on the 1st of July 2020. So counting from July, from February to July, that will be almost 5 months. So that will be almost 5 months because we count February, March, April, May, June, July. So on the July 1, on the 1st of July, you don't count that. So we are going to have 5 months as our period in this case. We are going to have 5 months. So we are calculating the total amount that Simon is owing, yes, in that 5 months. How are we going to do that? We are going to, since it's compounded, yes, since it's compounded compounded monthly, here in this case we are going to use a formula. Remember, it's 7.2 7.2.1. So we're going to use a compound formula to work out this, so that we know the total amount owing to the financial institution on the 1st of July. So it will be 1 plus I to the power of n. Then we have 10,000 as our present value there as given. Then we have 1 plus, all right, so we have 9.5%, guys. That's going to be 0.095 divided, since it's compounded monthly, they said compounded monthly. Okay, so we are going to put 12 here to the power of 5. Remember, from February to July, remember that they said calculate the total amount owing to the financial institution on the 1st of July 2020. So you won't count July, but you're going to count from February to June. On the 1st, you'll be able to pay that financial institution on the 1st of July 2020. So in this case, what we are going to say, we're going to put 5, not 6, no? So not 6. So what are we going to do after that? We will work out this using our calculator. So all right, let me just use this one. So it's going to be 10,000. 1 plus 0.095 divided by 12. Remember your period, it's 5 there. Then we're working with months. You don't have to multiply the months. If you're given, if they want you to calculate in months, don't multiply the period. No, unless if we're working with years, so we will multiply the period. Okay, so in this case we have 10,402, comma 15 rand. That's the amount. That's the total amount owing to the financial institution. That's the total amount he's owing. Simon, this is the total amount Simon is owing. He's owing around 10,402 and 402 rand, comma 15 cent. Yes. So now let's go to 7.2.2. How many months will it take Simon to repay the loan? Okay. How many months? We are looking for the period here. In this case, we are looking for the period. They said how many months will it take Simon to repay the loan? So we are actually looking for N. So since it's a loan, guys, remember when it's a loan, you're using a present value. But when you're talking about the retirement annuities, savings account, sinking fund, you will always use this formula. You will always use this formula, 1 plus I to the power of n minus 1. This is for future value. For future value. But if this is when they talk about the retirement, savings account, and as well as when they talk about sinking funds, you can use this one. But when they talk about loans, loans, guys, and bond repayment, you can use this formula. 1 plus I to the power of negative n divided by I. So this is the formula you're going to use. So you just have to know your story. So here they said, how many months will it take Simon to repay the loan? Okay, let's put that into practice. Write your formula there. PV is equals to X. Okay, 1 plus I to the power of negative n divided by I. So we already have the present value. This becomes now our present value, which is 10. This is the accumulated amount. So it becomes our present value, which is 10,402, 15. So we have our monthly payment, which is that was given as 450. Okay, 1 plus 0.095 divided by 12. Then we are looking for n, which is the months, right, in this case. So you're going to divide both sides by 0.095 divided by 12. So the best way, guys, here is to multiply everything by 0.95. Multiply here, we're going to multiply by 0.095 divided by 2, this and this, then they will cancel. Then as well here, you're going to multiply by 0.095 divided by 12. So here, we'll be left with 450 as well as 1 plus 0.095 divided by 12 to the power of negative n. We're working it out. So let's take our calculator there. Let's take this for 10,402 and multiply it by the interest. So it's going to be, let's see, 0.095 divided by, is it what, 12? Ne? So 12 since it's compounded monthly. So we have, seems as I'm not doing it well. 10,402, 15 times 0.095 divided by 12. Okay, we have 82. Really? Oh, let me punch it again. 10,042, 15 times 0.095 divided by 12. Okay, all right. So punch it. Let me punch it again. When I punch it again, all right. So I'm having that 80 something. No? So to make life easier here, this is what I'm going to do. Remember that we have 10,402, 15 times 0,095 divided by 12. So to make life easier, let's also divide everything by 450 here. Divide everything by 450. So this and this, they will cancel. So let's punch this now. Togetherness. So we have what then? We have 10,402, 15 multiply by 0,095 divided by 12. Okay, divided by 12 down, that's 450. We're having, you can see 0, we are having 0,183 and 00 and blah blah blah. So as well as here we are having 1. So let's work out what is inside the brackets. So what is 1 plus 0,095 divided by 12? That gives us 1,079 blah blah blah. Yes, and blah blah blah. Okay, to the power of negative n. Yeah, that's what it gives us. So what we could do is take this to the other side, take 1 to the other side. So remember that we have 0,183 and 300 minus 1. Okay, we could take that. So all right. So right. So when we transpose this one to the other side, what are we going to get? If you punch your calculator there, you can see that now. Let me punch it again. Right, I'm having a 0,8169, and here I'm having 1,079 to the power of negative n. So now I can use, to find n, I can use logarithm here. So it's going to be, since we do not have the same base, so I'm going to say log base. Our base is this, which is 1,079, and as well as this, then 0,1869, then which is equals to negative n. Okay, which is equals to negative n. Log base, remember it's log base number, which is equals to exponent, which is negative n. So let's punch this in a calculator. So we have log put that 1,0079, then as well as 0,8169. This gives us 25, something 7 blah blah blah. So all in all, then when you round off that thing, it gives us negative blah blah blah, negative 25 and comma blah blah blah. So after that you divide by, when you round off this into 1 decimal places, we are going to have n as 26. So all in all, we have 26 months. 26 months. That's what we are having, guys. That's what we are having. No? Now, guys, I want us to look at the last one. What is the balance, the BO, the balance of the loan immediately after Simon has made the 25th payment? Let's put that into practice. All right, guys, 7.2.3, what is the balance of the loan immediately after Simon has made the 25th payment? 25th payment or 25 payment. So we are actually looking for BO here. So BO, which is balance outstanding, we're going to write the formula. It says P is equals to 1 plus I to the power of n minus we have what it's gonna be, since you're using a future value formula when you're working with BO, because you'll receive that money in future. So it will be X future value formula then divided by I. So what are we going to put here at the balance outstanding? Remember that we had our present value as 10,402, right? When we work out that. So we have our values as what? 10,402, 15, as well as 1 plus, remember the interest is still the same, 0,095 divided by 12 to the power of what? To the power of 25. Then, okay, minus our monthly payment was given as 450. Yes, we're given as 450. Right, so we have that as well as 1 plus 0,095, okay, divided by 12 to the power of 25 minus 1 divided by 0,095. So let's calculate our balance outstanding, our BO, balance outstanding. Let's put that into practice. So we have 10,000. We have 10,000. Okay. 10,402, 15. Sorry for that. 1 plus 0,095 divided by 12 to the power of 25. Okay, let's go. Let's finish up. Minus we have 450 as well as 1